Welcome back. Now that we hopefully have a little bit of an intuition of what a limit is, or finding the limit of a function is, let's do some problems. Some of these are what you might actually see on your exams, or when you're actually trying to solve a general limit problem. So let's say that what is the limit? Once again, my pen is not working. Let's see, make sure it's working. What is the limit as x approaches, let's say, -1? And let me see, what's a good, let's say my expression is, let me put it in parentheses so it's cleaner. Say it's 2x plus 2 over x plus 1. So the first thing I would always try to do is just say, well, what happens if I just stick x straight into this expression? What happens? Well, what's 2x plus 2 when x is equal to -1? It's 2 times -1, 2 times -1 plus 2 over -1 plus 1. Well, the numerator is -2 plus 2. That equals 0 over, and what's the denominator? -1 plus 1 over 0. And do we know what 0 over 0 is? Well, no, it's undefined, right? So here's a case, just like what we saw in that first video, where the limit actually can't equal what the expression equals when you substitute x for the number you're trying to find the limit of, because you get an undefined answer. So let's see if using the limit we can come up with a better answer for what it's approaching. Well, since we're just starting with these limit problems, let me draw a graph, and I think this is going to give you the intuition for what we're doing. It'll probably give you the answer, but then I'll show you how to solve this analytically. So if I draw a graph, so these are the axes. Actually, probably I'll do the graphical and the analytical at the same time. So I'm going to rewrite this expression in a way that maybe I can simplify it. So 2x plus 2, isn't that the same thing as 2 times x plus 1? I see this pen, this tool. 2 times x plus 1, right? 2x plus 2 is the same thing as 2 times x plus 1. And then all of that is over x plus 1. So as long as this expression and this expression don't equal 0, it actually turns out that this function, let's say that this is f of x, right? This function. Well, for every value other than x is equal to -1, you could actually cancel this and this out. And so really we see that f of x is equal to, I need to find a better tool, f of x is equal to 2 when x does not equal -1. And we saw when x is equal to -1, it's undefined. So undefined when x equals -1. So how would we graph that? We showed that f of x is equal to 2 when x does not equal -1, and f of x is undefined when x equals -1. And once again, all I did is kind of rewrite this exact same function, right? I showed that I could simplify and I could divide the numerator and denominator by x plus 1 as long as x does not equal -1. And then otherwise, it's undefined. So let me graph this. I'm going to get a different color. Maybe I'll go with red. There we go. So this is 2. So we see that x is, and let me say this is -1. So for every other value other than -1, the value of this of f of x is equal to 2. This is just, this is 1, this is 2, this is 3. I don't know why my pen stops. This is 3, so on. At -1, the graph is undefined, so there's a hole there, and then we keep going to the left-hand side. So if we're going to do the limit, we can just visually say, well, let me do another color now. As x comes from the left-hand side, as x goes from this side, what does f of x equal? Well, f of x is 2, 2, 2, 2, 2. F of x is equal to 2 until we get to exactly -1, right? And similarly, when we go from the other hand, it's the exact same thing. F of x is 2, 2, 2 until we get to -1. So you'll see, I mean, and actually you see it visually here, that the limit of x, the limit as x approaches -1 of 2x plus 2 over x plus 1, it equals 2. Let me draw a line here so you don't get messed up with all the work. And I'm not formally, I guess, proving here that the limit is 2, but I'm showing you kind of an analytical way, and this is actually how it tends to be done in algebra class, is that you tend to simplify the expression so that you say, oh, if there wasn't a hole here, what would the f of x equal, right? And then you just evaluate it at that point. I think this might give you a little intuition, but this isn't a formal solution. But unless you're asked to, you tend not to be asked for a formal solution. You actually just tend to ask what the limit is, and this is the way you could solve it. And actually, another way that I often used to check my answers when I used to do it is, you could take a calculator and try in, what happens when, what is f of minus 1.001, right? And you could also try what is f of negative 0.999, right? Because what you want to do is you want to say, well, what does a function equal when I get really close to -1? And then you could keep going closer and closer to -1 and see what the function approaches. And in this case, you'll see that it approaches 2. So let's do another problem. Well, let's say, what is the limit? What is the my pen? Oh, I'm in the wrong layer. What is the limit as x approaches 0 of 1 over x? I think here it might be useful to draw this graph, because it'll give you a visual reason, a visual representation. Actually, let's do it both ways. Let's do it the picking numbers method, because I think that'll give you an intuition, and maybe it'll help us draw the graph. So let's say that this is f of x. Let's say that f of x, you can tell my presentations are very unplanned. F of x is equal to 1 over x. And we want to find the limit as x approaches 0. So what is f of, actually, let's make a table. F of x. This tool, x. So clearly when x is equal to 0, we don't know. It's undefined. It's 1 over 0 is undefined, which is, so we get undefined. But what happens when x equals minus 0.01? Well, when it's minus 0.01, 1 over minus 0.01, that is equal to negative 100, right? What happens when x is equal to minus 0.001, right? So we're getting closer and closer to 0 from the negative direction. Well, here it equals, let me make sure my pen is working, get the color right. Something's wrong with my tool. My computer is breaking down. Let me see what's going on. I think my computer just froze. Well, I'm going to try to solve this, and in the very next video, I'm going to continue on with this problem. So I'll actually see you in the next presentation while I figure out why my pen isn't working, and then we'll continue with this problem. See you very soon.